This video goes with Kuta handout number 14, and this is the video B, the middle part of the handout. So right now we have a term that has an exponent, but it's raised to an exponent. And we got to remember with our rules that this exponent on the outside applies to everything to the left, and because it's grouped, that means that we have to take 2x cubed and raise it to the third power. So I'm going to write this in expanded form just so you can understand why the rules work. 2x cubed raised to the third power really means 2x cubed times 2x cubed times 2x cubed. And if I just stop there and don't try to expand it anymore, I can really apply my rules from the previous part of the handout. I can multiply the coefficient, so 2 times 2 times 2 is 8. And then I can use my rules that when I multiply exponents with the same base, I keep the base and I add the exponents. So 3 plus 3 plus 3 is 9. So I end up with 8x to the 9th power. But I'd rather not do that. I'd rather just apply some rules or to simplify this to make this a lot easier. So I'm going to start with this problem right here, problem number 23. I'll do 24, I guess. 23. Remember, that's raised to the 4th power, so now I got to take everything inside the parentheses to the 4th power. So if I do, and I better check on my calculator here, if I do 6 to the 4th power, I get 1,296. And then now we can apply the power rule. M to the 3rd power raised to the 4th power. Remember, we're just going to multiply. 3 times 4 is 12, and that's the shortcut. Let's go ahead and see if we can do this for a few more examples. 6x squared raised to the 3rd power. Remember, we're going to apply that to everything inside the parentheses. So 6 to the 3rd power is 216. And then x squared raised to the 3rd power. We're going to multiply the exponents, so keep the base. 2 times 3 is 6. We'll do a couple more examples. Let's do problem number 26. This 2 applies to everything on the inside. So 7 squared is 49. And then n to the 4th power raised to the 2nd power, keep the base n, and 4 times 2 is 8. Apply that rule for all of them. The next part of the handout, though, deals with some negative exponents. And so when we look at 31 all the way through 42, anytime we have negative exponents, we want to try to make them positive, but you got to remember to make something positive, it's going to go downstairs in the denominator of a fraction. And recall that exponents only apply to the first thing to the left of the exponent. So in the case of problem number 31, b to a negative 2 power, that negative 2 exponent only applies to the variable b. It does not apply to the 8. So if I want to set this up as a ratio, here's my fraction. Everything that's positive is going to stay on the top. Anything that's negative, I'm going to bring downstairs. So up on the top, I have the term 5b. And then times, well, I can leave the 8 up here, it's positive, but the b to the negative 2 power has to be brought down in the denominator to make it positive. So when I simplify, I'm just going to go ahead and bring this down. 5 times 8 is 40, and I still have my b, so 40b. And then, of course, on the bottom I have b squared. Well, just remember, this means 40 times b. And down here we have b times b, and we're using the same rules that we used in the earlier part of the handout. b goes into b once, b goes into b once. So the only thing I have left is I have 40 over b. That would be a simplified form. And let me see if I can make that look a little bit nicer. So 40 over b. I'm going to do a couple more examples, so this is going to disappear. Let's see, something else with negative exponents is what I'm looking for, because anytime we have negative exponents, we want to kind of make them into a ratio. So let's start with problem number 35. Let's see what's going to stay on the top and what will go down to the bottom. Let's see, my positive 6, the coefficient can stay up there, but a to the negative 3 power, if I want a positive, has to go downstairs. Let's see, times 8, my coefficient can stay up there, it's positive. But a to the negative 2 power has to go downstairs if I want it to be positive. And let's see if I can simplify this. Let's see, 6 times 8 is 48. On the bottom, I can use the rules. If the base is the same, keep the base and add the exponents. And let's try one more. Let's see, let's do problem number 42. I look at problem number 42. Let's see, I'm going to make a ratio because I have negative exponents. Let's see, the coefficient 2 can stay up here because it's positive, but x to the -1 power has to go downstairs to become positive. Let's see, the 3x squared, it's already down here, so times 3x squared, we're going to leave it down there. Let's see what happens. Let's see, I have 2 on the top, and down on the bottom I have, well, there's really a 1 here that we're not showing. So 1 times 3 becomes 3, and then x to the first power times x to the second power, and keep the base, add the exponents, and I think I'm done there. This concludes part B of the videos.